Good afternoon, everyone. Today we are going to discuss about elective A hydrogeology. Okay? Elective A hydrogeology. Now, today and tomorrow we will discuss two chapters. Okay, today I will cover hydrogeology part 1 and part 2 also. Okay, block 1, block 2, and block 3, block 4. Okay, total 4 blocks will be covered in 2 days, today and tomorrow. Okay. And today just we'll go with the introduction part of hydrogeology. What is hydrogeology? What are the different types of concepts or different type of contents covered in hydrogeology, like aquifer system, okay, and hydrogeological cycle, or next hydrogeological cycle, and in that evaporation, okay, condensation and precipitation, infiltration, runoff, and unit 2 will discuss about the distribution and occurrence of groundwater, how it will be distributed and it will be occurred, okay. And the groundwater occurrence, and unit 3 will cover aquifer properties and Dot's law, and aquifer properties like porosity and permeability will discuss Dot's law, formula, and the groundwater flow patterns are the chapters or units we are going to cover today. Okay. In first slides or first presentation. In second presentation, we'll cover the detailed contents of the hydrogeological or hydrogeology concepts. Okay. So what is hydrogeology? And what are the type of aquifers, wells, and groundwater flow we'll discuss as able to you are able to observe in this picture. These are the aquifer system. This is the geological rock formation, different type of geological rock formations. Just a minute. Okay. These are the different type of rock formations. Okay, these are the which are having the groundwater, and these are the borewells. Okay, these are the tube and borewells, and these are the streams. Literally. And here you can observe this is another aquifer and this is another aquifer. Okay, and this is the groundwater. This is the groundwater, and this is the another water level which is covered in the confined area. Okay, so in detail we are going to discuss in the upcoming classes, upcoming slides. Okay, now what is hydrogeological cycle? You need to hydrogeological cycle. Here you can observe. Okay, overview of the hydrological cycle we discuss here. Description. Okay, what is the description of hydrological cycle? Is the continuous circulation of water between the earth's surface and the atmosphere. The continuous circulation of water between the earth's surface and atmosphere. This is called as hydrogeological cycle. Okay. And process. What are the process involved in this hydrogeological cycle? Are evaporation, condensation, okay, and precipitation. You can say this is the precipitation, infiltration, and runoff. These 1, 2, 3, 4, 5. These 5 processes will be included or involved in the hydrogeological cycle. Here you can see in this picture. So from oceans, okay, from oceans, here you can see. From oceans, precipitation will be from oceans evaporation, and from the river soils and lakes. These are okay, evaporation. Then condensation or moisture they will be traveled one place to another place. Condensation, then precipitation. Here and here you can observe precipitation. Okay. After precipitation, some water will be infiltrated and some water infiltration will be there. and some water will go as a runoff. Okay. Into the streams or major rivers. Okay. Then it will go to the, here you can observe this is the precipitation. Okay. From oceans, evaporation. Okay. Then cloud formation. Then rain clouds and precipitation will be there. Some water will be go as a runoff and some water will be infiltrated. This is the infiltration. Okay. To the soil. Okay. Or pore spaces. Okay. Infiltration will be there after raining and runoff will be there. So runoff, this runoff water form the small stream to the major river system. Again, this major river system will travel some time and it will go to the oceans again. So this is like a cycle. Okay, this is like a cycle, hydrogeological cycle. So evaporation, condensation, okay, and precipitation, infiltration, runoff. So these all five processes will be there in the hydrogeological cycle. So overview of the hydrogeological cycle is description the continuous circulation of water between Earth surface and atmosphere, and process is evaporation, condensation, okay, precipitation, infiltration, and runoff. Okay, you can see the evaporation, okay, condensation and precipitation, infiltration, runoff. Again, we'll go to the major river system and oceans. This is the complete hydrogeological cycle, which is covering the five processes: evaporation, condensation, precipitation, infiltration, runoff. Okay, if you are able to remember these keywords, you can write the entire question, theory question. Okay. Next, what is evaporation? Okay. Evaporation. What is evaporation? Definition is, okay, evaporation. Evaporation is the process by which water changes from a liquid to a gas or vapor state due to the heat, okay, heat energy. And factors affecting evaporation rates are temperature. High temperatures accelerates the evaporation process, and humidity, lower humidity increases the evaporation rate, and wind speed. Again, wind speed, wind speed, increased wind speed enhance the evaporation process. So from oceans, evaporation will be done by these factors like temperature, high temperature, humidity or low humidity, and wind speed. These three processes are affecting factors. Evaporation will be occurred, and due to the evaporation, water vapors will transport and will join in the or will form the clouds. Okay, or air moisture clouds. Next, condensation means forming of the clouds, formation of the clouds with the air moisture. Okay, formation of clouds with the air moisture. Okay, so condensation is the definition like condensation is the process by which water vapor changes into liquid, water, or solid ice. Definition is condensation is the process by which water vapor changes into liquid, water, or solid ice. Formation of clouds. Condensation of water vapor onto part particles in the atmosphere from clouds. So this is the formation of clouds. Next to precipitation. Here you can see in the picture. So form of precipitation. In precipitation, rain will be there, Snow will be there, sleet will be there, hail will be there, drop will be there. So these are the different type of the precipitation. Okay. So mostly five type of precipitations are there. This you can see this is the condensing water vapor. After it will rain will be occur or rain will come called as precipitation and moisturizing air. So one side of the hill or upside of the hill will be get the more rainfall because of this condensation and moisturized air mixture. Okay, and outer side or downstream or downside of the hill may not have that much of rainfall because of this side only most of the rainfall will be occur. Okay. And rain shadow region we call as rain shadow region or other side of the or downside of the hill. Dry descending air will be there. Here you can most moisture or rising air will be there. So due to the this rising air, moisture air and this condensing water vapor clouds, when rain will be occurred and most of the rain will be available or covered in the upside of the hill. Okay. Next, most of the downside of the hill or other side of the hill may not get that much of rain. So these region called as the rain shadow region. Okay, this region called as rain shadow region. Okay, we'll go for a definition. Definition is precipitation is any form of precipitation is any form of water that falls from the atmosphere to the earth surface. Precipitation is any form of water that falls from the atmosphere to the earth's surface. Types of precipitation, rain, snow, sleet, and hail. These are the main types of precipitation types. Examples are monsoon rainfall in the Western Ghats region, okay, and which contributes to the India's water resources and snowfall in the Himalaya region, vital for river flow during the summer months. So these are the main examples which are occurred in the our Indian continent or peninsular India or Himalaya region. So definition is precipitation is any form of water that falls from the atmosphere to the earth's surface called as precipitation. And types of precipitation majorly are rain, snow, sleet, and hail. Okay. And examples are monsoon rainfall in the Western Ghats region, which contributes to the India's water resource, and snowfall in the Himalaya region, vital for river flow during the summer months. So these are the main examples of the precipitation process which is involved in the hydrogeological cycle. Infiltration. So what is called infiltration? So after precipitation, okay, some water will be infiltrated into the subsurface of the earth or rock formations through the soil water storage process or pore spaces which are present in the geological formations. So soil water storage, then percolation to the deep groundwater, and some of the infiltration water has converted into streams also, and again it will join in the streams through the subsurface. And most of the water after infiltration, most of the water will goes to the rivers as a runoff. Okay. After rainfall, infiltration will be there and most of the water will transported as runoff. Okay. And it will join the main streams or main rivers. And some of the infiltration water also, it will go to the main streams through the subsurface and some part of infiltration water. Okay. Some amount of infiltration water will store as a groundwater. So after precipitation, rainfall will come. The rainfall, two process will be there. One is infiltration, one is runoff. Runoff water will be joined into the streams or infiltration water. Again, it split into the, it will some amount of water, it will go to the streams through the subsurface, and some amount of infiltrated water stored as a groundwater. So this is infiltration and runoff process, which is included in the hydrogeological cycle. Definition is the process by which water seeps into the soil or porous rock layers on the ground surface is called as infiltration. Infiltration is the process by which water seeps into the soil or porous rock layers on the ground surface called as infiltration. Factors affecting infiltration rates are, okay, soil type. Sandy soils allow for rapid infiltration, while clay soils impeded it, because sandy soils may have the high porosity, okay, and clay soils may have the low porosity and low infiltration rates. So where clay is present, there will be a less infiltration rate and a higher runoff. Okay, and where sandy soils are present, there will there will be a higher rate of infiltration and lesser amount of runoff return will be there. Okay, this is the infiltration process. And the vegetation cover also will hold some amount of the water which is coming the precipitation or rainfall. Vegetation enhances infiltration by reducing surface runoff, because vegetation may cover or hold some, mm, will hold some runoff water, and it will increase the infiltration rate by holding some water, and it is reduce the alternately, it will reduce the surface runoff rate. Okay, the best examples are infiltration rates in the Indo-Gangetic Plain. Okay, Indo-Ganga plains influenced by the region's agriculture practices and soil characters. Because of these Indo-Gangetic plains may have larger delta plains or alluvial plains. Okay, these alluvial plains or delta plains may have high porosity or high infiltration characteristics and lesser runoff runoff conditions. So when alluvial fields or sandy fields or recent river fields are present, where deltas is present, there will be a higher rate of infiltration will be occurred, and lesser rate of runoff will be occurred. But in higher rate of infiltration in this Indo-Gangetic plain also, again it will join into the main river system or main streams through the infiltration subsurface process. Okay, some amount of water will be stored as groundwater, and remaining also subsurface flow to the streams will be there. So this is the best example in India in northern part Indo-Gangetic plains. Okay, this is the infiltration process. Next, we'll go for the runoff. What is the definition of runoff is? Runoff refers to the flow of water over the land surface into streams, rivers, and other water bodies. Okay. Runoff it refers to the flow of water over the land surface into streams, rivers, and other water bodies, called as a runoff. And types of runoffs are surface runoff will be there, interflow will be there, and base flow will be there. As we have discussed in the previous slides, subsurface flow will be there. Okay. After infiltration, some amount of water will again join to the streams through the subsurface flow or base flow. Okay. So base flow will be there, interflow will be there, and runoff will be there in runoff. Okay. Next, best examples are runoff from the Western Ghats feeding rivers like the Godavari and Krishna, circular for agriculture in peninsular India. Most of the peninsular India covered with these Godavari and Krishna river system. These are the best examples for runoff. These are the runoff procedure, which is mostly dominantly you can observe in the peninsular region or southern part of or middle to southern part of India. In northern or northeastern part of India, we can observe the infiltration process because of soil conditions. Whereas in Western Ghats in peninsular India, we can observe the runoff procedure or runoff process because of rock conditions, soil conditions. Okay, because of geological conditions, we can say. So based on geological conditions, these groundwater or water or rainy water will converted into, based on geological conditions only, it will converted into infiltration process, runoff process. In runoff, base flow will be there, surface flow will be there. In infiltration, some water stored as groundwater and remaining water again it will join to the streams through the subsurface flow. And in the unit 2, distribution occurrence of groundwater will discuss. Okay. Here, how groundwater will be distributed, how this groundwater will be occurred, we'll discuss in the unit 2 in our syllabus. Okay. So here you can see, here you can see overview of groundwater and distribution. Okay. Description. What is groundwater? Groundwater exists beneath the earth surface. Groundwater exists beneath the subsurface or surface in the geological formations known as aquifers. Okay. And factor influencing occurrence of groundwater is geological structures, climate, vegetation, human activities. So geological structures and climate and vegetation and human activities also will influence the distribution and occurrence of the groundwater. Here you can see, this is the, here you can see after vegetation or surface of the earth. Okay, sir, this is the surface of the earth. This is the surface of the earth. Here you can see surface of water. This is the bottom of the ocean or whatever streams. Okay, this is the land surface. Okay, this is the vegetation. Okay, these are the vegetation. Okay. Now, after surface of the earth, this region called as unsaturated zone. Okay, this region you can see without water. This without water zone called as unsaturated zone. After this water table in the same aquifer same aquifer, the empty space called as unsaturated zone and water table below zone is called as saturated zone and water which is presented in the saturated zone is called as groundwater and the surface of the saturated zone, this is the surface of the saturated zone called as the water table and upper part of water table called as the unsaturated zone and lower part of the water table called as the saturated zone. Okay. And you can see here, tries to drop air with the water. Okay. Blue color, you can see this is the water in the cracks or whatever. Okay. And gaps. Here also gravel is some part of the rock formation having the air bubbles. Here, okay, these are the air. And this is the water, okay, present in the rock system of rock formations. So this region called as a unsaturated, okay, and this region called as a saturated because all empty places, all pore spaces are available. Empty places which are present in the geological rock formation called as the all empty places which are covered with or which are filled with the water called as the saturated zone. All the pore spaces in the rock formation or geological rock formation partially filled with, okay, partially filled with the water and air. Here also partially filled with water and air. This region called as the unsaturated zone. So upper part of the saturation zone is called as the water table. Okay. And below this water table region called as saturation zone, and which water which is present in the saturated zone called as a groundwater. Next, groundwater occurrence. Okay. So here you can see this is the clouds due to the precipitation or raining. So infiltration will be there in the cracks of the soil or geological rock formations. Okay, this is the infiltration process, and this is the runoff process to the streams. And here also we can observe infiltration process. Okay, and this line called as the water table because of upper part of the this water table called as unsaturated zone, and below this water table called as the saturated zone because it is having full of water. All empty places, all pore spaces are filled with water only. There is no air in the this saturated zone or groundwater zone. Okay, and these are the cracks or fractures or uh, gap spaces which are present in the rock formation, also filled with the water. And here you can see water and air will be there. But here you can see water stored underground in cracks and pore spaces. This region called as groundwater zone or saturated zone, and this region called as unsaturated zone. Okay. And groundwater occurrences. Definition is, you can write, groundwater occurs in the pore spaces and fractures of aquifer. Type of aquifers are unconfined aquifer. Okay, confined aquifer. In unconfined aquifer, an aquifer where the water table intersects the land surface. Okay, this is called as unconfined aquifer. And confined aquifer, an aquifer sandwiched between impermeable layers. This is called as unconfined and confined aquifer system. So unconfined is a aquifer where the water table intersects the land surface, and in confined, an aquifer sandwiched between the impermeable layers called as the confined aquifer. And best examples are Indo-Gangetic Basin aquifer system and one of the world's most extensive groundwater systems circular for irrigation in the northern or northeastern region of the India. Next, Unit 3, Aquifer Properties and Dorsila. So what is the aquifer we have seen and how many types are there? Confined, unconfined is there. What is unconfined and what is confined we have seen in the previous slides. Now we'll discuss about what is the aquifer properties and is there any scientific study related to the aquifer properties. So these we are going to discuss in the these slides. Okay. Introduction to the aquifers. Description. Aquifers are geological formations capable of storing and transmitting groundwater. Importance. Serve as vital water source for drinking, irrigation, and industrial purpose. So, introduction to the aquifer is description. Aquifers are the geological formations capable of storing and transmitting of groundwater. It has to be store means groundwater has to be stored and groundwater has to be transmit. Okay. So whether the geological formation will having storing and transmitting properties, then only we can call as a aquifer or good aquifer. Okay. And importance serves as vital water resources for drinking, irrigation, and other industry purpose. Okay, here you can see in the picture confined and unconfined aquifers. Okay, see this is the confined aquifer because it is sandwiched. This is sandwiched between this layer or this layer. This is the okay impermeable layer. This is impermeable. So this permeable aquifer is sandwiched between this impermeable two impermeable layers. called as confined aquifer. And whereas unconfined aquifer, it is exposed to the atmosphere, or it will cover the unsaturated and saturated zones in the geological rock formation. So here you can see this is the water table, okay. And confining unit to unconfined aquifer. This is the unconfined. This is unconfined, this is the confined. This is sandwiched between two inferior layers, and whereas this is open to the, you can see this is the table intersects the land surface. So land surface, when it is intersects the land surface, is called as unconfined. When it is sandwiched between impermeable layers, we can call as the confined aquifer. See, these two borewells are located or drilled in the confined aquifer. Okay, because these confined aquifer water level is higher than the this borewell. That's why it is flowing without pumping system. We can call as flowing artesian well, because this groundwater level of the unconfined aquifer is more height, okay, more height than the this drilled borewell surface. Okay. Next, this is borewell located in the perched aquifer in the unconfined aquifer. Okay. And this is also located in the unconfined aquifer. And again, this is located in the confined aquifer. See here, this is the water table of the confined aquifer, where it is lower because it is flowing without pumping system, without electric power. And here you can see this is not flowing without any pumping system. Okay, here we have to install pumping system. Here we need not to install pumping system because this confined aquifer water level is higher than the head of the this borewell. Here you can see head of the borewell is higher than the water table of the confined aquifer, because here we have to install the pumping system. So this is the confined and unconfined conditions of the aquifer systems which are present in the subsurface of the earth as a geological formations. Sorry. Now, here you can observe. It's okay. Aquifer parameter. Okay. What is the parameters or properties of aquifer? So, porosity, as we have discussed earlier, porosity is there, permeability will be there. Okay. Porosity, permeability. Porosity, percentage of void spaces in a rock sediment or rock or geological rock formation. Percentage of void spaces present in the rock system called is the porosity. Whereas permeability, ability of a material to transmit fluid. As we have discussed earlier, what is aquifer? It has to store water, it has to transmit water. Then only we call as good aquifer. So in aquifer, these two properties are important. One is porosity, that is percentage of void spaces which are present in the some volume of rock or formation. Is the ability of material or rock formation to transmit fluids, to transmit groundwater. That is called as permeability. And best examples are Deccan traps, basalt aquifers in Maharashtra, known for the known for their high permeability and groundwater storage capacity because of weathering conditions and all. So it may have wide spaces, and those are filled with the water. Okay. Here you can see this is the sand grain, and this is also another sand grain. In between here you can see observe pore space. This pore space is filled with water, means it is saturated, and it is filled with some water and air means unsaturated. Like that entire water, entire rock or entire rock formation. Okay, if it is able to store water and transmit, we can call as this formation is having good porosity and permeability conditions. Where you can see this is cementing material. Here you can see these rock particles or sand grains having the cementing material. It may not allow the water into the or saturated water into the pore spaces effectively. So this is having poor porosity and permeability because of cementation. Here you can see there is no cementation. It will store and it will permeable. It will permit water to transfer or it may have the transmit condition. Okay. Next, here you can see pore spaces are filled with water and here pore spaces are filled with water. Unfractured shale may have some less amount of or very small amounts of pore spaces between clays and slight grains and silt grains. So it may have lesser amount of groundwater availability. Here you can see this is the fractured shale because fracture condition it will connect all the pore spaces or all the void spaces or all available void spaces it will connect because of fractured nature. So it may have good porosity and transmissivity also because connectivity is there in all gaps or void spaces. So it may have, this aquifer may have the porosity and permeability. This may have porosity but permeability less because of there is no connectivity in the these filled water gaps. Okay. So here you can see this the here also connectivity there and water is there. Porous, porous sandstone. This is cemented sandstone. In cement in nature, it may have water, but it may not permit the water. It may not have permeability because of cementing nature. And shale unfractured may have porosity, but may not have permeability. Here, fractured shale may have porosity and permeability. So these are the two types of conditions based on aquifer parameters. Next, next to dorsilla. So how we will measure the this porosity, permeability, okay, and transmissivity of an aquifer or any geological rock formation. So we have some formula that is called as Darcy's law. So based on this permeability, porosity, and transmissivity, storativity conditions, we have created some Darcy's law. So Darcy has created this uh, formula. Okay. So one statement is describes the flow of groundwater through porous media. Flow of it will describes the it will measure the okay it will measure the it will measure the groundwater flow rate or flow of groundwater through the porous media or geological rock formation media. Flow of groundwater through the geological rock formation media is called as Darcy's law. That is that is formula is Q equal to K multiply A multiply H minus and H2 by L. This is the height 1 and height 2 of the this porous media and L is the length of the porous media and A is the area of the porous media. So and K is the transmissivity. Okay. So this is the Q equal to K into A into H minus H2. So Ed minus Ed2. Ed1 minus Ed2 by L. This is called as Darcy's law. Here you can observe the if you if you take this as a one geological rock formation or some porous medium, some aquifer. Okay. This is the H and this is the L. H is the L1 minus H2 or H1 minus H2. This is the head loss of first and second. So this is the difference. Okay, this is the difference. So H1 minus H2. This is the head loss or H. And this is the circular part. This is the area of the this forest media, or this is this aquifer system. So the rate of flow, the flow of groundwater, the flow rate of groundwater Q is calculated with the H, L and area and and transmissivity capacity of the particular given aquifer system. This is called as Darcy's law. Application of Darcy's law in estimating groundwater flow rates in the aquifers, Aravali aquifer system of Rajasthan, and circular for water supply in the region. So this is one of the best example in the uses of the Darcy's law, which is presently we are following in the Rajasthan Aravali aquifer system. Okay. Next, groundwater flow pattern. Okay. Description. Okay. Groundwater moves through aquifers in response to hydraulic gradient. Okay. And flow direction and velocity influenced by hydraulic conductivity and gradient. So gradient and conductivity, okay, will be influenced. Okay. The flow direction and velocity will be influenced by hydraulic conductivity and gradient of the aquifer system. Okay, and for example, groundwater flow patterns in the Kaveri Basin aquifer supporting agriculture and drinking water supply in southern part of India. So this is the one aquifer system. This is one aquifer system. Okay, and this is the area of that aquifer system. The V is the velocity. Okay, and gradient is the gradient. So V equal to d by t. Okay, transmissivity and gradient. So this is the groundwater flow pattern. Okay, next, next we'll discuss the about um, discuss about the time now. Okay, 10 minutes. Huh? Next we'll discuss about this. Yes. And now we'll discuss about so the introduction part of this black 2, okay, groundwater exploration. So what is groundwater? Now we have discussed in today class hydrogeological cycle, what is the aquifer types, what are the processes involved in the hydrogeological cycle, like evaporation, condensation, precipitation, infiltration, and runoff, and aquifer systems, type of aquifers, unconfined and confined aquifers, okay, and what properties of aquifers like porosity and permeability, and formula which is related with the groundwater flow rate through the porous media, that is Darcy's law. Also, we have covered in the also we have covered in the also covered in the today's presentation. Now just we'll discuss about the groundwater exploration part, introduction part. Okay, water is a vital for a development and industrial growth, particularly where surface water is scarce. Growing population and demands for irrigation, domestic and industrial use have strained water resources. Groundwater exploration is essential for effective and sustainable water management. Proper exploration techniques are crucial from a source location to well design and construction. These are the processes which are involved in the groundwater exploration, and these are the conditions which are involved in the groundwater exploration. Okay, the growing population and demands for irrigation, domestic and industrial uses have strained water resources. Okay, and groundwater exploration is essential for effective and sustainable water management systems. And proper exploration techniques are crucial from a source location to well design and construction. These are the important procedure or process which are involved in the groundwater exploration. Next, groundwater occurrence and aquifer. Okay, what are the groundwater occurrence and aquifers? Just now we have discussed, and distribution of groundwater in geological formations. Also, we have discussed, okay, how it is unsaturated zone, saturated zone. Also, we have discussed methods of geological exploration. We have to discuss, okay. So, if you take this groundwater potential zones, which are the best potential zones, which may give best groundwater resources, and which area may not have sufficient water. Like that, we can identify with this or locate with this groundwater potential zone map. Okay. And next we'll discuss about the geophysical exploration for groundwater. Okay, in groundwater exploration, we will use geophysical techniques or geophysical methods like resistivity. Okay, in resistivity, we'll use Schlumberger and Werner configurations for groundwater exploration and mineral exploration. Okay, or vertical and uh, profile so research or studies or data collection. Okay, next. Electrical resistivity methods, electrode configuration and sounding curves, barometric techniques, and electrical resistivity tomography and data processing will also will discuss in the next class. And these are the different type of the data. Okay, processed data images of the resistivity, tomography and resistivity, different type of curves. Okay, and this is the Winner array and this is the Schlumberger array, which may useful in the groundwater exploration methods. Okay, and these are the seismic wave types, which is also helpful in the exploration part of groundwater. And reflection and diffraction methods also will use, and understanding remote sensing and GS, reading the GS and all geomorphological features and okay topographical features. Okay, and all satellite images processing and use of these techniques for groundwater exploration is very essential nowadays. This is the large scale exploration part which is covering in the groundwater exploration or identification of different type of groundwater potential zones with the larger scale or a larger area we can cover with this remote sensing and GS techniques. Whereas in geophysical and seismic, smaller area or look targeted area only we can cover. Whereas the remote sensing and GS techniques, we can in the less time we can cover or we can quickly monitor all the potential zones or we can identify all the potential zones in the larger scale. Okay, larger scales. Application of remote sensing and GS in groundwater studies is the groundwater potential zone prepared by GIS and remote sensing methods. So these are the next upcoming syllabus contents or syllabus which is present in our elective A groundwater exploration. Today we have covered the hydrogeological cycle, what are the important process of the hydrogeological cycle, and what are the aquifer systems, what are the properties of aquifer system, okay, and what are the formula which is involved in the aquifer flow rate identification, and what are the different type of groundwater exploration, why we call as groundwater exploration, where we have to explore groundwater, and how we identify groundwater potential zones, how you have to prepare groundwater potential zones, what are the different type of data collection or data collected methods involved in the groundwater exploration like remote sensing, GIS, and geophysical seismic methods. This we have discussed in today's class. Okay, this is the second presentation in our groundwater exploration syllabus. Next, tomorrow we are going to discuss about the remaining. Tomorrow we'll discuss about the groundwater contamination and groundwater management studies. Tomorrow we are going to discuss. Okay, this is the groundwater contamination or pollutions related to the groundwater and groundwater management also. Tomorrow we are going to discuss as a two presentations. Today we have covered two presentations. Okay, and tomorrow we are going to cover two presentations which may cover groundwater contamination and groundwater management. Okay, methods. Thank you. Try to read or write down the keywords which are more important in the theory exam. If you are able to remember the keywords, you can write easily. You can write theory part of your elective hydrogeology subject. Okay. Thank you. Sharing.